Title: Physics Demystified. A kinetic journey through the world of forces, energy, and motion. Welcome, fellow adventurers, to the wacky and wonderful world of physics. Buckle up as we embark on a hilarious journey through the mysteries of forces, energy, and motion. But don't worry, I promise to keep the equations to a minimum after all. Who needs math when you've got jokes? First up, let's tackle forces. Picture this. You're trying to push a giant boulder up a hill, but instead of making progress, you end up doing the cha-cha with the boulder, as it stubbornly refuses to budge. That's Newton's first law of motion for you. An object at rest tends to stay at rest, especially when it's as stubborn as a mule. Now, let's talk about energy. Imagine you're a superhero with the power to shoot laser beams out of your eyes. You're all fired up and ready to save the day, but suddenly you realize your laser beams are about as powerful as a flashlight at a rock concert. That's the law of conservation of energy. Energy can neither be created nor destroyed, only transformed. Looks like you'll have to settle for being a mediocre superhero for now. And finally, let's dive into motion. Picture yourself on a roller coaster, screaming your lungs out as you zoom down a steep drop at breakneck speed. Suddenly, you're hit with a blast of wind so strong it nearly blows your toupee off. That's the exhilarating thrill of Newton's second law of motion. Force equals mass times acceleration. Who knew physics could be such a wild ride? But fear not, brave adventurers, for I've prepared some handy drawn formula pictures to guide you through the maze of physics equations. Think of them as your trusty sidekicks, ready to lend a hand or a laugh whenever you need them. So strap on your safety goggles and get ready to laugh your way through the wild and wacky world of physics. Remember, in the world of science, the only limit is your imagination and maybe the occasional bout of uncontrollable laughter. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity, and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Title: Exploring Fundamental Physics Concepts Through Practical Examples. Introduction. Welcome to an exciting journey through the fascinating world of physics. In this comprehensive guide, we'll explore three fundamental topics: electromagnetism, mechanics, and thermodynamics. Through practical examples and exercises, we'll apply the same equations and formulas to consolidate our understanding of these concepts. So, grab your lab coat and safety goggles, and let's dive in. Topic 1. Electromagnetism. Example: magnetic field of a solenoid. Consider a solenoid with 100 turns of wire and a current of 2 amps flowing through it. Using the equation for the magnetic field inside a solenoid, B equals 1/4 euros Ni, where B is the magnetic field strength, 1/4 euros is the permeability of free space, N is the number of turns per unit length, and I is the current. Calculate the magnetic field strength inside the solenoid. Exercise. Using the same solenoid as in the example, calculate the magnetic field strength at a point located 5 centimeters away from the center of the solenoid. Assume the solenoid has a radius of 3 centimeters. Explanation. To solve this exercise, we can use the equation for the magnetic field of a solenoid. First, calculate the number of turns per unit length, N, by dividing the total number of turns by the length of the solenoid. Then, use the given current, I, and plug in the values into the equation to find the magnetic field strength at the specified distance from the center of the solenoid. Topic 2. Mechanics. Example: projectile motion. Imagine a baseball player hitting a ball with an initial velocity of 20 meters per second at an angle of 45 degrees above the horizontal. Using the equations of motion, calculate the maximum height reached by the ball and the horizontal distance traveled before hitting the ground. Exercise. Consider the same scenario as in the example, but this time, calculate the time of flight of the ball. Assume no air resistance. Explanation. To solve this exercise, we can use the equations of motion for projectile motion. First, calculate the time it takes for the ball to reach its maximum height, using the equation for vertical motion. Then, use this time to calculate the total time of flight, which is twice the time to reach maximum height. Topic 3. Thermodynamics. Example: ideal gas law. Suppose we have a container filled with 2 moles of an ideal gas at a temperature of 300 K, and a pressure of 1 atm. Using the ideal gas law, PV equals nRT, where P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. Calculate the volume of the gas. Exercise. Consider the same scenario as in the example, but this time, calculate the pressure of the gas if its volume is doubled while keeping the temperature constant. Explanation. To solve this exercise, we can use the ideal gas law equation. Since the temperature remains constant, the equation simplifies to PV equals PV dot. We can use this equation to find the pressure of the gas when its volume is doubled while keeping the temperature constant. In conclusion, by applying the same equations and formulas to practical examples and exercises, we can deepen our understanding of fundamental physics concepts such as electromagnetism, mechanics, and thermodynamics. So keep practicing and exploring, and soon you'll be a physics pro. In addition to the detailed explanations and exercises provided in this video, it's essential to highlight the importance of engagement and interaction with the content. Liking, sharing, and commenting on the video not only show support for the effort put into creating valuable educational content, but also play a significant role in increasing its visibility and importance within the online community. Liking the video is a simple yet effective way to express appreciation for the information presented and the effort invested in creating it. It signals to the creator that the content resonates with the audience and encourages them to continue producing similar high-quality content in the future. Additionally, liking the video can help improve its visibility on YouTube, making it more likely to be recommended to other users who may find it useful or informative. Sharing the video with friends, family, or fellow enthusiasts expands its reach and allows more people to benefit from the valuable knowledge shared. By sharing the video on social media platforms or with relevant online communities, you're helping to spread awareness and contribute to the collective learning and growth of others. Commenting on the video provides an opportunity to engage with the creator and fellow viewers, share thoughts, questions, and feedback. Constructive comments contribute to the overall conversation surrounding the topic, and may even prompt the creator to address specific inquiries or concerns raised by viewers. Additionally, comments contribute to the overall engagement metrics of the video, further boosting its importance and visibility on the platform. Finally, subscribing to the YouTube channel ensures that you stay updated on future content releases and never miss out on valuable information and insights. Subscribing also shows support for the creator and encourages them to continue producing high-quality content for their audience. In conclusion, liking, sharing, commenting, and subscribing to the YouTube channel associated with this video are essential actions that contribute to the success and impact of the content. By actively engaging with the material, you not only show appreciation for the knowledge shared, but also help to amplify its reach and importance within the online community. So don't hesitate to like, share, comment, and subscribe. Your support makes a significant difference.